Okay. So using change of base formula here, you should have log 3 divided by log 243. And you're going to get 1/5. So what this actually means is that you would have to find the 5th root of 243 to figure this out without the change of base formula. And who wants to do that? Not me. Okay? There's your answer there. There's your answer there. Questions about change of base? Okay, let's do one that's really nasty that is just going to give you a decimal. Let's just do log base 4 of 37. So that'd be the log of 37 divided by the log of 4. So giving that to 3 decimal places, 2.605. See, that's super gross. The only other alternative that you could use here, right, like if you forgot the change of base formula, you'd be forced to do this. 4 to some power equals 37, and you just have to guess and check until you figured it out, right? Who wants to do that? We already did that, and it was awful. So now we appreciate the logarithm because it makes our lives easy. Okay. So that is the change of base formula. So that's subheading 1, right? Now we're going to go to another different type of skill. And so this is solving exponential equations. Exponential equations. And this is important with like bases. So they're just like with the logs, we had like 2 different methods to use. Same thing with the exponential equations. So solving exponential equations with like bases. So here we go. All right, let's try this one first. This one's pretty easy. So that's 6 to the 3x, 6 to the negative x. I'm going to do it, and then I'll go back and offer a slower and more thorough explanation of what I did. So for this one, I'm just going to do this. Dun, 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 dun. So the reason I've been doing that is because, remember with the logs, if they both had the same base, we could just take the argument out. Well, now we can just take the powers and set them equal because they both have a like base. So I just took the powers, set them equal, and so this will now be 3x plus x equals 0. That's 4x equals 0. Divide by 4, and you just get 0. So if the bases are the same, set the powers or the exponents equal. We'll say exponents, that's clear. Set the exponents equal. So notice how sometimes I write these little notes out to the side. That's one of the things you can be doing in your the skills part of your portfolio. So when you're working on a problem, just tell me what you're doing, right? So bases are the same. We just set the exponents equal and solve for x, and that's a done deal on that one. Why don't I like divide by x at this step? I mean, you won't have an x left, right? Both the x's will go away, and we definitely don't want that because then you'll just have 3 equals -1, which is crazy. All right, let's do another one. I don't even need that. Example. It is hot in here. Would you mind clicking the air on for me? Just clicking from heat to cool, and it should already be set. Because otherwise we're going to die. Okay, thank you so much. Let's do another one. So this is 5 to the 2x equals 625. So we're going to solve this one using like bases too, but unfortunately that's not the case that it's in right now. So I'm going to see if I can write 625 as a power of 5. And you can just check in your calculator, right? 5 to the third is 125. 5 to the fourth is 625. So I'm just going to rewrite that number. So 5 to the 2x equals 5 to the fourth. And see, now I have the same situation that I had previously. I just had to rewrite this in a different form. Now I can set the exponents equal to each other, and from here, I mean, it's fairly simple stuff. Okay, let's do one that's a little uglier. Let's do 27 to the 3 minus x equals 81. So notice, like in the one before, I had a 5 and I just had to make the other one match, right? Well, I can't raise 27 to any power and get 81, so it's going to have to be something else. I'm going to have to change both of them. What's a number that I can raise to a power and get both of those numbers, 27 and 81? 9. 9 will work for 81. Will it work for 27?
It's 3.
9 to the third power is
2. You need 3 for the base.
You do need 3 for the base, right? So my immediate start is going to be like 9 squared is 81. But then I'm going to try to write 9 to some power to get 27. It's not going to work. So I've got to go lower than that. It's going to be 3. So 3 to the third power will give me 27. And then I've still got this power out here, right? What's 3? 3 to the fourth is 81. Let me double check. I'm pretty sure, but I want to double check. Yeah. So all I did here, just to use some color to bring your attention to it, is I just took that 27 and rewrote it. And I did it in parentheses because I got this other power out here, okay? All right. Well, that's gross. I'm going to have to deal with that first. Recall your powers of exponents. If I have a power raised to another power, I multiply. So that would be 3 to the 3 times 3 minus x equals 3 to the fourth. And so then this would be 3 to the 9 minus 3x equals 3 to the fourth. And now I've got those bases that are the same. Everything's nice and clean, so I can go ahead and just drop the bases and set the exponents equal. Let's see, we'll add 9 to both sides. We'll have negative 3x equals, or subtract 9 from both sides. That'll be negative 5. Divide both sides by negative 3, and we will have 5 over 3. So until you get really fluent in your powers of low numbers, you're going to try something and then you're going to be like, that's not going to work. And then you'll be able to move through a little faster. Again, this is just powers of exponents. This times this. Multiply that through, set the powers equal, and it's a done deal. All right, let's do another. We good here? Questions? And so far, you can ask me later if you need to. All right. 243 divided by negative x minus 3, or to the power of 81 to the x plus 1 equals 1 over 9. It's hideous. It's hideous, right? So I'm going to walk you through my thinking briefly, and then I'll go back and expand a little more on what I'm doing, okay? first thing is I don't like this fraction. Do we like fractions here? In general, people say no. This is 9 to the first. So how can I make this not a fraction? The negative first power will bring me up top. So let me do that first. I do a lot of rewriting problems. Okay, so now this is 9 to the negative 1, and now I feel a little bit better about it. So at this point, I've got to write all three of these numbers with the same base, because none of the exponent rules work until we have like bases. Can we raise 9 to a power to get 243? Well, 9 squared is 81, and 9 to the third is 729, so that's not going to work. So my next option is 3, right? How do I know the next option is 3? Right, because there's only one thing that's going to work for that 9, and that's 3. So let's rewrite all of these as powers of 3. That 243, I don't know, I'm going to have to do some checking. 3 to the 5th. So that's 3 to the 5th power, and negative x minus 3. I said a minute ago that 81 was 3 to the 4th. So that's x plus 1. And then we have 3 squared to the negative 1. So see how by this point, like all the little things I've taught you, we're kind of smashing them all together and using every bit of it. So now that I've got my stuff rewritten, I need to handle these exponent rules. And so all this will be multiplied. So this will be 3, negative 5x minus 15. I'm just distributing this 5 times 3. I'm going to distribute the 4 now. 4x plus 4 equals 3 to the negative 2. Now we're going to have to pull up some new exponent rule we haven't used in a minute. Remember, when we have a power raised to a power, we multiply them. But when we have this situation, we add the exponents. So we'll combine like terms. This one's very easy. So this will be 3 to negative 5 plus 4x will be just negative x. Then negative 15 plus 4 will just be negative 11 or minus 11 equals 3 to the negative 2. So remember the log, we wanted a log equal to a log. Now I want an exponential equal to an exponential. So now we can just drop everything and just do the powers. Add 11 to both sides, you'll end up with 9. Divide by negative 1, negative 9. All right. Let me go back up and talk through it. Okay. This one's long. All right. So the first thing is I do not like the fraction. It messes with my brain. I do not like it. I'm going to make that into a not fraction just by making that a negative 1. So it'll move up because I changed the sign of the exponent. Now I have this. Just like when there's a bunch of logs separated, I can't do those cool tricks. I can't do that here either, so I've got to deal with all this. I need them to be like bases, so I wrote each of these as a power of 3. Exponent rules say I multiply these two things together, so I distribute the 5, I distribute the 4, and I just multiply these two numbers together. Right here, I'm going to okay, I got to add these exponents. So I just combine like term, negative 5x plus 4x is going to give me negative 1x. Negative 15 plus 4 gives me negative 11. So now I'm at this point. I have an exponential and nothing else. Okay. So at that point, I can use my trick of just like bases, just take the powers and set them equal. So a lot of steps. That's probably as gross as it will get with one of those. All right, last subheading of the day. This one is solving exponential equations without like bases. Without like bases. So solving exponential equations without my bases. This is a new trick, but it works the same every single time, which is usually comforting. So, all right. So let's say we have 7 to the n equals 13.7. So notice how like we've got that same thing that we did with the logs, where instead of having, something to a power and something to a power, I've just got the power and then it looks some random number over here. So what we're going to do is I'm going to do it and I'm going to explain why I did it, okay? I'm going to take the natural logarithm of both sides. Remember, I can do whatever I want as long as I do it to both sides. So I just took the natural log of both sides. So remember the power rule where any exponent swings out front? Well, we can rewrite this as n times the ln of 7 equals the ln of 13.7. Remember we were expanding and condensing. Any logarithm with a power inside can come out front as being multiplied. All right, well, we're trying to solve for n. These two things are multiplied together, and this is just a number, so I'm going to divide both sides by the ln of 7. Well, n's by itself, so I'm done. And this is just a number. You can put it in your calculator and approximate it like to the nearest 3 decimal places. This is the ln of 13.7 divided by the ln of 7, and you'll see that that's about 1.345. This is just an application of the power rule. Okay? I choose to take the ln of both sides here. Number one, because the ln will go in my calculator, right? I can put that in my calculator. So I like the ln. When I apply the log to both sides, I can swing that exponent down. I know how to solve for this. I don't know how to solve for this. Now I can just divide whatever isn't in. So that'll do. Let's do another one. Questions so far? All right. Let's do another one. Let's do negative 11x equals negative 87. So one quick side note, I need you to know how to read this, because what this is not negative 11 raised to the x. It is 11 to the x with a negative out front. Do you see the difference? No?
Yes.
Okay. Why is it important that I know this? Can we have negative bases for exponentials? Do you remember that from the homework? We had this, we talked about this like a week ago. You can't have 1 to the x is not exponential, 0 to the x is not exponential, and any negative number is not an exponential. So we did that. You remember? Okay.
Yeah.
So that's why it's important, because you automatically think the negative 11 is all raised to a power. I want to make sure you know that it isn't. So I want this by itself. So I'm going to divide by negative 1 on both sides. Here you go. Okay, take the ln of both sides. Swing the power out front. x times ln 11 equals ln 87. Just to show you with color, we're trying to solve for this guy. So let's divide both sides by ln of 11. And then to the nearest 10. Goes in the calculator at that point. ln of 87, ln of 11. 1.862. I told you it was going to be boring today. It is what it is.
At least it's making sense though.
That there is that. Good. I'm very glad. All right, let's do another one. Pattern recognition. There's just a lot of little details that I need to show you. That's why there's so many examples today. The procedure is not really changing. All right, so we got 3 to the n equals negative 27. Notice the exponential is all by itself. So I'm just going to go ahead and take the ln. So I'm just going to abort there. Can't make that look right. Okay, so immediately at this point, this is what I know. No solution. No solution. And here's why. Negative in the argument. Negative in the logarithm. Not cool. Notice that did not happen over here because we were able to divide out that -1 and make it positive. Yeah, that's not going to happen over here. You know, you could like, even if you don't recognize it right off the bat, you would get to the end, and when you plugged it in your calculator, it would tell you domain error. Okay, just FYI. So if you don't catch that right from the beginning, you'll get a domain error later. But anytime you have a log or a natural log of a negative number, that's going to yield a no solution. Like if you don't believe me, you can just put it in your calculator right now. ln of negative 27, domain error. Okay, not happening. All right, that's that one. Let's do another different case. Let's do this one. -7 times 20 to the a power equals -51. I cannot take the ln yet because the exponential is not by itself. It's got something hanging out here. So I need to divide by that -7 first. So this will be 20a equals 51 over 7. That's just an ugly fraction. It's not going away. It's not a big issue. Now I can take the ln. So this would be ln of 20 to the a equals ln of nasty fraction. Apply that power property, and it's just going to drop down front here. A times ln of 20 equals ln of 51 over 7. And if you ever get lost because there are so many letters, go back and find what you're solving for. I'm solving for a. So everything needs to go away from a. So I'm going to divide by ln of 20. And this all goes in the calculator. Once the variable is by itself, goes in the calculator. That's how you know when to stop. ln of 20, 0.663. The key here that I'm trying to illustrate to you is that in order to apply this trick where you do the ln, the exponential has got to be alone. Because if you do it before, it's going to give you some gnarly answers, right? And so you're going to get stuck. All right, I'll do one more. One more, and then I'm going to let you work for the rest of the block. Example e to the 9x minus 3. equals 26. I'm going to do this one the long way, and then I'm going to show you a shortcut. Right? All right. The exponential is by itself, just something to a power, so let's go ahead and take the ln. So again, this is the long way. So you'll drop out the entire power over here. Because that whole exponent's going to come down front. Okay, let's see. Well, this is multiplied. So I can't do anything with this. So I'm going to divide first. So this will be 9x minus 3 equals ln of 26 over ln of e. Well, remember, if we're lost, we need to remind ourselves what we're actually doing here. We're solving for x. And so we'll add 3. So there's not ln of 26 divided by ln of e plus 3. And then we'll divide by 9. That's super gross, right?
That is disgusting.
Hmm?
That is disgusting.
It is disgusting. However, a couple of different shortcuts you can take here. Number one, if you remember that the ln of e, that's an inverse, that can just immediately go away. And then we can just skip to this. Right? You can mark that out immediately. What's the ln of e? Put it in your calculator. Yeah. So, you can just remember that here, or you can remember that ln and e cancel each other out. And so your shortcut would send you this way. So we would then have, remember we were doing that earlier when we were solving. So this would then just be 9x minus 3 equals ln of 26. So this would be x equals ln of 26 plus 3 divided by 9, which is much nicer. But if you want to do this, then you can. It'll work. But it's just kind of hard sometimes to recognize that ln of e. But if you see it, it just goes away. But if you were to plug all this in, it'd still be the same. Bless you, believe it or not. Do you like the black way better or the blue way better? The blue. So always look. ln of e, just right gone immediately, which is most excellent. So if you're looking for shortcuts, that's definitely one of them. Anytime you have ln of e to the x, or if you have e to the ln of x, this stuff cancels. Okay. All right, let's practice. So I posted your practice in Classroom. I have 2 different things I want to talk to you about real quick. So the practice, it does say do them all. And so that, in my professional opinion, is what you need to do in order to expose yourself to the appropriate amount of practice to see all the different types of problems. But of course, I'm just going to ask you if you have questions tomorrow morning. But I feel like you need to see them because usually this part is the part of the test where people do the worst. Okay. Second thing, and I'm going to put the key up in just a second as well. So as you're working, you're not blind and you can ask any questions. The second thing is if you look at Google Classroom, there's also a Delta Math posted for you, which is optional. But I want to just show you. Let's see. See it, test bonus points and skills review. So this is a Delta Math that is due, if you choose to do it, by the beginning of class on Friday. And if it is completed and you turn in the work, which is notes required, you'll show the work and then turn it in. I will take whatever grade you get on the test And I'll take 15% of that and I will add it on to your final grade for the test. So if you make 100, 15% of 100 is 15 points. So you'll get 115 in the grade book. Okay? But it has to be completely done, and I've got to see paper that corresponds to the work. But it is optional for you. I will say to you that the average grade on the logarithm and exponential tests last semester was like a 55.
Good to know.
Yes, it is a difficult test, and people often underestimate the practice it takes to know what you need to know. But that was made to help you with that, and also to kind of give you a help if you struggle on the test. So, but if the secret is, if you do that, you're not going to struggle nearly as much on the test because you'll know what you need to know. But it is optional. You'll have time pretty much the whole time in class, except for your homework check to work on that in class tomorrow. But I wanted to post it today in case you wanted a head start. Okay? And that is it. So you got practice over the new skill. I'm going to post the key for you. You're welcome to work some on the Delta math. It goes all the way back to the first day.